Okay, now we'll have to find out the roots of the equation x cube minus 2x minus 5 is equal to 0. Okay, so what was our first step? So this is a function which is a continuous function, and what was our first step? Just rewind back. What was the first step? Yes, you have to find out A and B. Now, what was the condition that I have mentioned over there? Yes, such that f of A and f of B should be of opposite side. So let's have a look. Now, find A and B. So to find A and B, I'm going to put different values over here. Okay, so starting from 0, now I'm going to assign x is equal to 0, 1, 2, 3, etc. till I find an appropriate value for A and B. So just have a look at how I'm going to do that. Now if if x is equal to 0, then f of 0 is equal to what? 0 cube minus 2 into 0 minus 5. What is the answer? It is minus 5. So this is a negative quantity. Okay. Let's see another one. 1. So 1 cube minus 2 into 1 minus 5, which is equal to what? 1 cube is 1 itself, minus 2 minus 5, again minus 7, 1 minus 7 minus 6, so negative quantity. I'm going to see, if you consider this, these two are consecutive. Consecutively we are getting negative quantities. So that is not enough. You have to get a positive quantity right now. So if first you get a negative positive quantity, then make sure that you get a negative quantity in the next try. But since we got a negative quantity, we are hoping for a positive quantity right now. So but we got a negative quantity again. So let's see whether f of 2 will give us a positive quantity. Let's see. 2 cube minus 2 into 2 minus 5, which is equal to what? 2 cube is 8. 8 minus 4 is what? 4. 4 minus 5 is 1 minus 1. Again, it is a negative quantity. So we have to go one more time. Let's see. Now, f of 3. f of 3 is nothing but 3 cube minus 2 into 3 minus 5, which is equal to 3 cube is 9. 9 minus what? 2 into 3 is 6. So, sorry, 3 cube is 27. 27 minus 6 minus 5. It is nothing but 16. Okay, finally we got a positive quantity. Now I am going to tick mark these both equations, functions. So the first one I got a negative and the second it is a positive. So negative and positive. So I am going to take this and I am going to write over here that A and B, I found out A and B, and what is it? A is equal to 2. Since in our theory part I have said that f of A is, for my convenience I am making it as a negative value. You can take this as either B. Okay, for as of now I am going to take it as A is equal to 2 and B is equal to 3. So that means that somewhere between 2 and 3 lies the root of this particular function. So that was what step 1. Okay, we found out that A is equal to 2 and B is equal to 3. So as our theory demands, what we are going to do right now is we are going to bisect the interval, right? So we know that somewhere between 2 and 3 lies what? Our root. So I'm going to bisect. So how will I do that? A plus B divided by 2 is equal to 2 plus 3 divided by 2. That is equal to what? 5 by 2 is equal to 2.5. And I'm going to assign it to x naught. This is what you will be seeing in your step 2, right? Now, so I got what? X naught as 2.5. And the next step, what I have to find out? F of x naught, right? So why I'm going to do that? Because here it is saying I got x naught as 2.5. What does that mean? it could be the root, but I have to check whether it is the exact root or not, right? So for that, I'm going to do what? F of x naught is equal to f of 2.5, which is equal to 2.5, the whole cube minus 2 into 2.5 minus 5 is equal to, what is the amount that you get here? Please find out. Yes, you will get 5.6250, which is a positive quantity. It is not 0 that you get. You get 5.6250. So what you have to do next? Look back to your theory. The next step, what you have to do, if f of x naught is greater than 0, you have to change this value. B is equal to 3. But is there any change over here? No. So a is equal to 2. That remains like that itself. B will be equal to x naught, which is equal to what? Your x naught is 2.5. So B is equal to 2.5. So your new interval is nothing but 2.5. So that means that the root of the equation lies somewhere between 2 and 2.5. Now our the problem is not over. We are going for more iterations, right? Because why? We have to reach a point where f of x naught should be equal to 0. Now, this is the new interval, as I said, 2, 2.5. So, again, I'm going to bisect this interval. So, what I get? 2 plus 2.5 divided by 2 is equal to what? 2.25. So, this is x1. Okay, now, since this is x1, I have to find out what the next step is. Find f of x1. Now you find what is f of x1 and just give me the answer. Yes, the answer is nothing but 1.89065. Okay, now see, again this is not 0, this is a positive quantity. So what is the thing that you have to do right now? You have to change these values. Right, so since this is a positive quantity, will you change A? No. So A, I will write it like this itself. Will you change B? Yes, you will. B is 1.8906. Sorry. So B will be 2.25. So our new interval is 2, 2.25. And again you will have to bisect this, and a lot of numbers, you will be involving with a lot of numbers, and I would like to give you a look at what all numbers you will get, and I am going to put that in a table format. Okay.
So as you can see, here you will find 5 columns, and the first column is n. Now n represents the number of iterations, that is 1, 2, 3, etc. up to 12 iterations. Okay, now a is the a and b, that is the intervals. Okay, so the first the value of a was 2 and the value of b was 3. So I hope you know how we got 2 and 3. Just move back a few steps of the video and you will get the first step was to find out a and b such that f of a and f of b are of opposite signs. I hope you remember that. That is how we got 2 and 3 over here. Okay, then you got x. So I have given here x as a general value. So in the first iteration, now here n represents, as I said, n represents the iterations. For the first iteration, that is x naught. So 2.5 is nothing but your x naught. Just again I would ask you to go back to the first step. So you get 2.5 there as x naught, and here 5.6250 as f of x naught. right? So why we do go to the second iteration? That is because why? Yes, f of x naught is 5.6250. It is not equal to 0. So this value is not equal to 0. That is why we moved on to the second iteration. Second iteration also I have worked out. So there I got a as 12. There is, sorry, a as 2. There is no change because why? F of x naught was a positive quantity. So this I didn't change a, but I changed what? B, that is 2.5. Then from that I got x as 2.25, and then f of x naught, f of x1, I'm sorry, f of x1 was 1.8906. So till here we have done the what I have just written all the steps on the board, right? So from the third iterations I didn't do the steps since it's all repetitive. So again here this value is nothing but your x, f of x1, and since it is a positive quantity, it's not equal to 0. I moved on to the third iteration, and the third iteration, since this was a positive quantity, I just what the value of a was not changed, but yes, the value of b was certainly changed, and I got the x value 2.125, and here I got a positive value again 0.3457. So I want you to work out this third iteration. From third iteration onwards, I want you to work out and just compare the answers of what you get in your notebook with this table, and just see whether you are getting the correct answers as I have written over here in the table. Okay, so moving on, we move like this. So somewhere over here we get negative. So the place where we get negative, you can clearly see that the value of a is being changed from 2 to 2.0625, and there is no change in the value of b, that is 2.125 was there in the fourth iteration, but since it was negative, there was no change in the fifth iteration. I kept it as 2.125 itself, but again I got the f of x5 value as 0.0089, negative 0.0089. It was a negative quantity, so there also you can see that a is again changed, but the v value is not changed. So you have to note certain things. So this goes on like being positive to negative, but you won't be getting any 0. But when you come to the 12th iteration, after doing the calculations, you will get a value over here. So that this thing I have kept it as a blank because I want you to work out and see whether you are getting f of x is equal to 0 or f of x is equal to, sometimes you might not get a 0 exactly, but I just have worked out right now and I got it somewhat approximately to 0. So please do work out that, and make sure that whenever you do the calculations of these forms, you take the decimal points, like 5 decimal points like this, 0.9473, rather than rounding it up, so that you get a correct value. Okay, so I hope with that you have understood the table.
I hope you have understood the table, right? So from the table you have noted that, or noted that what we have done 12 iterations, and after getting the 12 iterations only, we got f of x is equal to 0, and hence the root of the equation is what? 2.09424. Okay, so that is the first method of understanding that you have to stop the iteration right over there. Now there is another option also. There is a second way of understanding of like when we have to stop this iteration. So the second method is by applying this particular formula. That is, this is nothing but b minus a modulus of b minus a divided by 2 raised to n should be less than epsilon. Now what is epsilon? Epsilon is a very small quantity. Okay. Epsilon is a very small quantity which is almost equal to what? 0. So I won't say it as a 0, but it is a very small quantity. So if b is equal to, now when you check at the 12th iteration, take those two numbers. I have taken those two numbers of a and b and I have subtracted them. I have found the difference. So I put the modulus sign over here, that's just because I don't want the negative value, only because of that. I just want to know what the difference is and if it is very much small. So that is only my concern. And so I found out the difference and divided by 2 raised to n. N means how many iterations I have taken. So in this case, I just came up to 12 and checked it. If you want, you can check it when it comes up to 6. But I don't think you will get a justifying answer for that, for this particular function. Maybe for other functions you might get. So for here, I just checked it when it came to 12th iteration, 2 raised to 12, and I found out that almost I got 0.00049, something like that. So I approximated the value like this, and yes, so that is how I concluded that this is again the root of this function. Okay, I hope you understood the problem. I would request you to go 2-3 times over this, because I have only discussed the problem which is involved with the polynomial function. I haven't introduced any transcendental function yet, so we will move on to transcendental function after only after you guys fully understand this way of solving this equation. Now just go through the problem and also compare it with your theory part, okay, and make yourself learn from that how to connect your theory and this problem part. So we will do another problem same type, just to make you thorough with the bisection method.